it might be good to think about what this means, and to maybe pause the video at some point here to really think about this problem rather than just waiting for the answer and seeing the answer. You might think sometimes it's like the first time you've seen a problem like this, so it's good to see someone do it and take you through it and all that. That's really not how one learns maths. One learns maths from really thinking about these things yourself, and getting comfortable with sort of not necessarily knowing what's going on and trying to overcome it. Okay, and then when you do have an idea, you might want to verify that it's similar to the idea I have, or if you don't have any ideas, that's when maybe you want to see a hint. Okay, but simply always waiting for the answer, even the first time, I think is not good for your development. Okay, so let's go into this. So we're trying to basically show that two states are equal, and I guess it's really impossible for sort of two statements to be like word for word equal. Like it's not going to be like the statement on the left is like if X is a dog, then X is a goat, and then on the right, then it has to be like if X is a dog, then it's a goat. So it's this equality it can't be that strict, or we'll never be able to succeed. So what we're talking about when we say equals is logically equal. So whenever the left hand side statement is true, the right hand statement is also true. Whenever the left hand statement is false, the right hand is also false. That's all we have to show. And well, whether the left hand or right hand side statements are true or false will depend on the true and false values of A and B. Okay, so basically to show that they're equal, we just have to really show all the possible true and false values of A and B produce the same true and false value on both sides. So for example, if we take true, A is true, B equals false, okay, then the left hand side, so if you remember what the negation does is it takes true to false and false to true. So left hand side is equal to the negation of true or the negation of false. So is equal to false or true, which is true. Okay, and then the right hand side is equal to the negation of false and true. Okay, but false and true is false. You need both things to be true for and to be true. So this is the negation of false, and the negation of false is true. So hopefully that even tells you, like, you if you can do the rest yourself, that's great, because it means you've realized that all you have to do is now try the other combinations of true and false. So try false and true, true and true, and false and false. Okay, so only 3 more possibilities. Okay, so let's suppose then left hand side, so if both are true, then the left hand side is false or false, and neither of them being true, the or is also false. So if it's false, the right hand side is true and true, so that's true. The negation of true is false. So see how both left hand side and right hand side are equal. A equals false, B equals true. Then the left hand side is equal to the or of true and false, which is true. And then the right hand side is equal to false the negation of false and true. So false and true is false. Negation of false is true. And then last one is false, false. That's the only possibility remaining. So the negation of false is true. So if true and true or true is true. So left hand side is true. And the right hand side is false and false. So false and false is false. Negation of false is true. So the right hand side is also true. This is equal to left hand side. So in all instances, the right hand side and left hand side are the same. So they're logically equivalent.